Wait, why did it just shift me over to some random thing? Yeah, the chat's just broken. I see it on YouTube here. That's so obnoxious, though. Oh, stream not found. No YouTube event. Hang on. What the heck? Check your YouTube dashboard. I really need something better than Restream. Yeah, Huh? That's bizarre. Well, I'm gonna leave the stream chat up, I suppose, so I can see it on the other monitor. It's not gonna show up here, though. That's super annoying. Freaking paid service just doesn't work half the time. Okay, so here's our forward pass. Oh, wait, this is actually informative, isn't it? Returned is just the white. Yeah, I'll try to catch both platforms. I don't know, it's just super annoying. Like, for reference, I have this dashboard that just like tries to combine all the streams, but it drops messages. It's like, I don't know. If anybody has a better alternative, by all means, but I need to get some real stuff done on this today. Okay, so let me take a look at this. This is 8.9 billion, right? Did I get this right? 8.9 billion, or is it 890? No, 890. Okay, look at this. Most of these element-wise kernels are in the forward pass, right? The reduced kernels are split. But then most of the kernels, I believe, are actually in the forward pass here. Which would make sense. So before we try to go write a before we go try to write a custom kernel for everything, let's just see. I'm gonna actually get myself one extra window here. Oh, cool. Yeah, I don't know what people use for multi-platform streaming. StreamYard, Caster, or Streamlabs. Do I need an application? Can I not just get something that hooks to OBS? So OBS is like the thing that I've found is the most stable across everything most of the time. I know Streamlabs is, well, maybe they have a plugin. I know they do have like a separate version of OBS as well. I want to at least get some. Stomach is not good today. Yep, I'll be right back. Whoa. I've been trying to improve my digestion for some athletics, and unfortunately that requires doing several things that mess it up first. So, ugh. I'll check out Streamlabs. Plug in for OBS. Okay, I will try that. Not right now, obviously. I'm gonna do this, but cool. Okay, so I'm gonna put my headset on because the friggin' dog keeps barking. Actually, you know what today's gonna be? Today's gonna be. I know what today is a good day for. Do I have my desktop audio muted? Cool. So I'm gonna put some quiet music in the background. So I got dogs barking. I got utter chaos here, and we are going to get good work done regardless. Let me get the YouTube chat. Cool. So what I wanted to do here was check what's in forward. Because I can't see anything else that would be in here other than this. Can you? I think it would be something like this. The log prob, graph state. Yeah, we're gonna have to have a little bit of a fancy setup to track all this. All right. So the goal here is just to narrow down where all these element-wise ops are coming from. And then we'll write a kernel once we know for sure. One moment. What are you doing to improve? Yeah, so I've had I've had a million doctors and none of it's worked. So I'm trying some stuff from the gym where they actually coach like serious athletes. Um, and there are a few different things. My case is a bit of a pain in the ass though, because I did a ton of damage to mine, like with all the caffeine studying through college. and then like several bad cases of like really bad food poisoning. So yeah, I've been trying to fix it for a long time. So I like at this point I'm just like, all right, we'll try a bunch of stuff. We'll see. Because otherwise, like you go to doctors and they just try to like they just shove pharmaceuticals at you. Like they'll just try to like give you Imodium or whatever. And it's like, okay, cool. This doesn't actually address the root cause. Like, good job. Oh, yes, sorry, Z. If you have diminishing returns PufferLib with a sim can't keep up. Scientific sim is really slow. Yeah, that's their problem, man. We're gonna fix that. This is the same thing with RL. RL people said, oh yeah, the sims can't be faster, and then I just made them faster. So yeah, it's not gonna help a ton right now on out of the box slow sims, but this is a really good test bed for us to improve the RL. We have been using it to improve the RL. The algorithm is better and more stable than it was before. We have better understanding of the algorithm now than we had before. The next version will give us better understanding than we have now. And additionally, we're also going to make the scientific sims faster. Antibiotics. Oh, yeah. I don't really have anything great, Jess. I've tried several things. I don't know. I tried Brian Johnson stuff for a bit, sort of helped. Tried AG1 for a bit, it sort of helps. Um, Actually, the gym they actually told me to try baking soda, which is funny because usually that messes up your digestion. We're gonna see whether that is the thing that has me all messed up this morning or not. It could be one of a couple things. I have a couple different probiotics to try as well. Um, Also, just diet consistent has to be very consistent for when I'm trying new stuff. There are quite a few things. Yeah, kind of a pain. The heck? Okay, so this is what we wanted here, guys. Look, you see this? We just, what did we just do? It's 16, 16, 7, 7.3. It's this element-wise kernel. Okay, that didn't help. Vectorized element-wise kernel, though, went down to 9. Oh, we killed off a bunch of these vectorized element-wise kernel calls. Look at this. This is plus 10% time going into the kernel without this. Okay, so this is unrolled element-wise kernel with 6.4. Okay, that didn't help. Reduced kernel. Oh, the reduced kernel is gone. Yeah, you see that? The reduced kernel is gone. So let's label this. This is most of the vector ops reduce kernels. I want to like really isolate where the hell everything's coming from though. Because we still have 22% element-wise kernel. You see this? I'm actually gonna give it Let's actually give this to Claude real quick. Okay. Yep, yeah, use the restroom again. This will be done pretty soon, though, and we'll be able to do kernel dev the rest of the day. Well, that is awful. Okay. I'm gonna let Claude take a quick look, um, just to see if I get anything that I have missed, and then after that, I'm going to just like start looking for ops myself. Stomach not good. You know, I wonder if it's because I took the baking soda at the same time as I took AG1. Probably like probiotics um plus like alkaline is not good. I don't know. Where'd you find this thing, dude? Huh? Are you sure? I don't think I have this in there. Oh, well, yeah, we do have the encoder. You're right. Cool. Okay, we got. Oh, did I miss? Hang on. It actually did have something good here. So, 400 mil. Wait, no, instances. 119K min group calls. And then element-wise calls will be, what's this, 60 plus 90, 150. Okay. Where'd you get 400K from? 260. Yeah, okay. 420. Four sources above, minus some that might fuse. Oh, it really just is fuse everything, huh? That's very irritating. Actually, I want to try that real quick, which is just take the biases out and just see. Oh, dot bias of false like this, right? I just want to see if this does it. Right, we get rid of the decoder like this. Oh, the value function has one too. Is that really just not built into the matmul or the kernel? That'd be so weird. Let's go. Does anybody know how important biases actually are? Because anybody actually tried in modern architectures? Okay, let's see if this actually takes ops off or not. It'd be funny if this does. I actually think that we're going to end up using some of Peru's kernels. He fused the value function. He fused like a couple of things. Actually, is there any reason not to just fuse the value function and the action output? Well, yeah, I guess because then you'll do split and you'll have like a cat backwards. Maybe not, actually. Maybe you won't. It's different gradients. Using Opus for real? Yeah, look how I'm using it though, dude. There are no vibes here. There's no vibe coding crap. The first stream I did was absolutely awful. I do not recommend that you do that in any way whatsoever. Yeah, no vibes. I mean, it's very simple. It's just like you just have to make a conscious decision as to whether you want to outsource your thinking to Claude or not. If you outsource your thinking, though, you like don't deceive yourself into thinking you have any value whatsoever on top of the tool that you're using. Like you either think and maintain control or you don't. I do not see a meaningful difference here. Anybody see a meaningful difference? No, they're all basically the same, right? And my setup worked, right? I mean, Drew is 20% more? No. Right? Yeah, no. I mean, it's actually a good thing if Torch has biases optimized, which it should. It really should. The fuck? What is it running? Oh, I see. What is that supposed to do? Like, you can run that, but what is that supposed to do? Fuse bias addition. Beta parameter. You can run that, but I don't think it's going to do anything. Oh, I see. It's running the profiler. Yeah, you can do that. That's fine. Gelu? Oh, if Gelu's multiple ops, that'd be really bad. Yeah, you can run that. It doesn't really need to be doing this, but that's fine. Well, that means we get our biases back, which is nice. One kernel. Oh, I see what it is. It's just trying to figure out what things are ops and what things aren't ops. I use the restroom yet again. I'll be right back, and then we will figure out. Essentially, we just have to figure out where all the element-wise ops are coming from, and then we will be solid. Oh, okay. Kublast doesn't fuse activations. What? Kublast does not fuse activations. Where did you get that from? Yo, where did you get that from? 1 to 2 kernels. Let me look that up. Oh, activations. Yeah, that's Gelu. It doesn't fuse the Gelu. Unless you have an epilogue, right? D-type conversions. Hang on. What? Huh? Why can't I type? Yo, I can't type. What? What happened? Oh, come on. We're gonna do this now, really? Let me go check my cluster. This is what I get for deving on a cluster. If I were just there in person, it'd be a lot easier. What's it called? What'll call it? I mean, I honestly think that the optimal workflow, oops, come on camera. The optimal workflow is to just have 2 desktops. Have yourself like a normal desktop that you do your work on, and then have one right next to it that you have, you have plugged in access to, wired access to, but you don't have monitors plugged in or like, desktop apps on or anything. Oh, everything is freaking down at 10:10. Lovely. You don't need an H200 node, dude. A 5090 desktop will do it. You can buy one for like 6-7 grand. Not like 40. It can't be a power outage though, because we have backup power. It must be an internet outage. That's some bullshit. Well, that totally screws up my work. That completely screws up my work. What do I do about this? I can set it up locally, but I can't run this stuff locally. It'll screw up the stream. I can get a vast box, I guess, but I don't really want to set that up. Okay. Great. I guess I have to get this set up locally now. That's like such bullshit. Man, everything just go wrong today. Holy shit, morning. And everything goes wrong this morning. Actually, I think NSYS won't screw up my stream. I think only NProf screws it up. Or NCU. Oh, come on, we're gonna fail on CUDA macros. I have Claude on here, I do. Billing. PI usage, cool. Wait, am I in Puffer? Yes, I am. NVIDIA Jetson board. I don't know. For RL, I just recommend people get good desktops. That's it. We have... Oh, do we not have CUDA at all? Great. CUDA tools 12. But then I have drivers for 13. Shit. I'm gonna just go keep checking whether my machines are back up. That's some bullshit. That's ridiculous. That can only be internet outage, I would assume. Because they're all down? Yeah, they're literally all down. Come on. Really, according to this, I have it. Okay, does this work now? Nice local version. Detected CUDA version 12. How is this the detected? Oh, I probably have the wrong, like, PufferLib. I probably installed, like, CUDA Toolkit or something. Okay, we'll just get ourselves a nice, like, little CUDA 13 local install, I guess. Okay, can we please now install this? We should be able to. Dude, that's some bullshit. Dude, why does this shit happen? This is why you always use Docker containers, by the way. This is why you always use Dockers. There's always just some dumb packaging bullshit. It's like, oh, you can just like, you should just learn it, and then it's no, it just nothing ever makes sense. Every freaking time, I swear. I've been doing this for 15 years, and stuff still doesn't make any damn sense. Packaging installs just mess up constantly. The cluster went offline, apparently. I think there's an internet outage, so I can't do much. I'm trying to set it up locally, but I don't actually have a good local setup at the moment. So I'm gonna try to get something set up locally so I can at least like do some profiling, but I'm not gonna be able to see if something's 10 mil or not. We'll get the local set up anyways, though. Luckily, I did push everything relevant. PRs, I could, but I'm supposed to have 10 mil today. We're starting a bunch of new client stuff this week, most likely, and I'd really, really like to be able to tell the new clients that we've got 10 mil in dev. I said I'd review PRs, but I want to at least hit the damn 10 mil, you know? Because, like, once I hit the 10 mil, then pretty much everything else is just cleanup. Until I hit the 10 mil, it's like, there's still outgoing, like, things to be discovered. Brain full. Okay, that actually ran. Can I train? Please train. Dude, what? How does training just, like, break everything like this? This is completely, like, hanging. Whoops. I don't understand. That makes no bloody sense. Look, yeah, this is why you use Docker. See this? If I'm having trouble with this is not PufferLib, by the way. Like, this is Torch and Cuda. Okay, this is nothing of PufferLib. Cycle, lovely. This work? Okay. Yeah? Okay, we have something. It's half speed because we're on a half price hardware. But it's actually still faster than Puffer 3 on the budget hardware. Okay. Next. I'm gonna run a couple myself first. This is a 5070, Jess. And, like, I don't know, some okay-ish CPU. Yeah, 8 core. Look what I'm gonna do. I just do this on everything, yeah? Oh, come on. I don't have the end probe script. I thought that I committed that, man. Now I don't remember the one-liner. Damn it. Oh, of course, right when I get this all set up, the internet comes back on the other boxes. Lovely. Of course. Just waste my time. Hell of a morning. I have not been paying attention to the YouTube chat because it has not been showing up properly. That's fine. Everybody moved over anyways. Are we back? No, I can see you. Oh, actually, now it does work. It randomly started working on YouTube again. So I think that the theme of this morning has been everything randomly breaks for no reason, and then everything randomly fixes itself without me doing anything. Cool. Let's hope this is stable for the rest of the day. I can't really do much if it isn't. Come on. Stupid hotkeys. All right. I'm gonna commit this before I forget it. Come on. What the heck is wrong today with this thing? One of these days, everything is just gonna work. There's not much to commit, actually. It's really just I need access to the hardware. Just... okay, let's go to... Jarvis. I don't want Jarvis, man. My main form factor... I want basically... You know, if I were to actually build, like an assistant, it would be kind of like this, except that it would not be put in this format that takes you out of your coding. It would just be the little pufferfish that sits up here puffing and spits out a speech bubble with stuff every so often and is actively just watching you as you're coding. It's preventing you from like doing dumb shit and like adding like non-distracting fixes in real time without breaking your train of thought. And then also takes voice input and then text output. That would be great. I actually don't hate the models anymore. I really don't hate the models. I mostly just hate the people developing them and their view of the world. course I know Clippy, dude. I'm not a Zoomer. I'm gonna be 29 in a couple days. Well, once you're 29, that means you've got 1 year left to be fitter in every possible way than you were when you were 20. That's how I see it. Me at 30 is gonna kick the shit out of me at 20 in every possible way. Been pretty good at shape at 20. I was in, let me think. I had not worked out in a bit, but I just stopped working out because I got to college. My best from that, I think when I was like when I stopped playing squash, my best was a 14-minute 2 mile, which I can do now despite being heavier. 15 pull-ups. I can do maybe 12 now, but I'm also way heavier. I could barely bench a plate. Now I rep 2 plates, no problem. Bunch of other stuff. So I'm doing all right. Gen Z, nope, I do not claim any affiliation with Gen Z. I identify as a boomer. Thank you very much. Gen C. Okay, what did this shit give us? Yeah, I'm in Florida. Don't want to be a boomer. I don't know. I definitely have the get off my lawn tendencies. 2 element wise. Yeah, we got 2 ops per layer, it would be. It's 2 ops per layer. How does a yellow account for 1 op? T-type conversion before replay. It could be that. Okay, so what do we have here? It should already be, in this case, low 32, right? I feel like way sharper today for some reason. Okay. Empty module holder, the hell? AI fix. Dude, I just ignore Twitter. People are so fucking dumb. Just ignore Twitter. Like, it will actually drive you nuts. I felt so much better because of all things, I've spent the hour that I would be spending like scrolling X playing RuneScape. That's the standard. Just build cool stuff. That chest environment is going to be awesome when it's done. Like, the thing is, most people actually don't care about progress or truth in any real sense. They just care about whatever stupid narrative makes them feel better. So, like, why bother listening to them? Where is this? How did I mess up the default encoder? I must have just missed something, right, while I was editing. Oh, you dummy. Yeah, I see it. I'm just dumb. Then in that case, I can do forward, replay. By this. I'm gonna try to just like post more high quality material on Twitter this year and spend less time just scrolling it. We'll see whether that's actually a good strategy for growth or whatever, but it's gonna be a way better strategy for having my mind clear to do work. Vibe coding once. I mean, like, I just translate that in my head. It's okay if somebody doesn't like thinking, or doesn't like not thinking and wants to think, but I believe not thinking will remain and continue to evolve. I think the thing that is missed here is programming is just about the damn closest thing we have to pure logic. Like, okay, yes, mathematics, but it's very abstract. Programming is very, very precise and concrete. You do not need to be a genius to get into quite a lot of programming. Um, but it's very, very much clear thinking. Way more so than writing. Writing is too fuzzy. So, what did I do here? What the heck happened here? Prof min. I actually don't understand. Oh, I know what happened. There we go. What do we have here? Okay, so this is still. How many of them do we have? Exactly two, pretty much. Yeah, exactly two per layer. You see this? Two per layer. Go look myself. Is it in here somewhere? Nothing should be a kernel here, though. Certainly nothing should be an element-wise op. Yeah, are copies element-wise ops, though? Like, element-wise kernel. You know what? Fine. We'll try this. Where's graph value.copy? I highly doubt this. Oh, I guess actually, that would be interesting if copies show up as these element-wise ops. I'd be pretty surprised about that. Is it going with Opus? I mean, it's just normal work now at this point, SD. I'm using it sometimes for some things, and I'm not using it for other things. What do we do? Quality Twitter content will help. Let's crash out more on stream. And I don't want to just be the dude that rants at everything. It just shit pisses me off. Like, I hope stuff doesn't just piss me off forever. I just, like, we build better stuff. We actually decide to use brains, and then I don't need to be pissed off anymore. But I don't give a shit what they're launching. They're a bunch of bastards anyways, I don't care. Okay, at the very least, right? Yeah, that didn't do it. Cool. Two of these per layer, right? Exactly. We're gonna comment out the entire frickin' loop and we're gonna see what happens, alright? Torch clamp is an element-wise op. Ooh. Okay. That is true. We're gonna try this. Let's see if they're in the copy clause. This stuff actually matters. Like, this is half of our perf on eval. Okay, that is 23 million SPS eval on a 5070. So, yeah, we still got overhead. We could very well hit 50 mil eval SPS on a 5090. Hmm. Hmm. We still have some Elmwise calls. Elmwise. Yeah, it's 1 for 2. Beginner in RL. Start RL from 0. What would you learn first? What's one small project? Jerry, I have a perfect article for you. So I get this question all the time, and I put together free, high-quality resources for just that. Here, follow this. This will take you through the process of building like multiple projects. I actually would suggest you do something if you're new that is way less time than 1 week. Like do something you can do in one evening, and then do something you can do in a few days. And if you're still on board after that, try something more ambitious. It'll take you through everything though. Oh yeah, and for folks watching, we are almost at 5K stars. So if you want to help me for absolutely free, just feed this puffer a star on GitHub. Thank you. That'll be useful for me too. Yep. I have multiple of those articles. I do produce a fair bit of educational content. Rollout calls and forwards. Oh, okay. 0. Is this actually this call 13% right here? If this call is 13% of the time, I'm going to lose my shit. I'm actually just going to lose my shit if this is 13% of the time is that 1-0 call. Per rollout car. Oh yeah, but this wouldn't be it, right? No, that wouldn't be it. 0 show up as? We'll check it either way. What if RL were just fast, guys, huh? What about that? No, we still got 13.8. Interesting. That actually doesn't make 0 show up at all. That's like completely wrong. Cool. Hey, mini brew gate. Oh, it's 2, right? Actually, I can figure this out. It's not going to be able to guess. Yeah, I can totally. Here. I know how we're going to do this. It's very easy for me to narrow this down. It's just going to take a few minutes. Here, let's just get me another window. I wish they'd not show up in the background like that. That'd be really nice. The Ubuntu windowing system is such a pain in the ass. All right. Cool. So, first thing we're going to do, we're going to go to rollout, play, like this. And we're going to comment the whole function. Bot commands for these. Well, sounds I'm on Twitch, YouTube, and X, so it's annoying. Okay. And I don't want to keep like delaying this release forever. But at the same time, we're so close to having this thing the perf target, and I'm so close to having something I am like truly proud of. You know? Okay. Element-wise kernel, 49,000 instances of element-wise kernel. $61K. Okay. There's still a bunch of element-wise kernels getting freaking called. Look at that. Maybe it was this. Oops. There should be 0 kernel calls. 0. Same thing. Calls, not this. Any other bullshit in this wrapper? Nah, there's nothing here. Nothing possible, right? It's gotta be in this function. Comment out the vec send and vec receive. I mean, we should not have to have any calls other than we should have some copy calls and we should have 2 kernels. One's a matmul, the other is the gate. Ooh, 161 mil. Well, okay, yeah, duh, because we gotta run the env. Okay, yeah, same thing. There's some variability. Same, but yeah. Not in the env. Not the env, guys. I'm freaking comment all this stuff. I just do not understand where this shit is coming from. Does not contain CUDA kernel data. That's what we want, right? There's a copy there. A copy there. There's a narrow call. Is it the narrow kernel? But that's not a kernel, dude. That's a slice. Huh? Profile in the forward pass. We're trying to eliminate, like, stupid, redundant kernels. Hey, Snowfall. Welcome. What the hell's this? Actually, I want to see. So this should be no kernels, right? Oh, you dummy. I just reran it, but whatever. I'm dumb. No worries. Wrong command. Is quick. So if this fails because there are no kernels, that's a good thing. Okay. Cool. There are no kernels in here. We don't need this one. Where is it? Right here. What do I think about AI safety? I think it's a legitimate topic that's discussed in often the stupidest way possible by the most out of touch people possible. Many of whom are actively just trying to con you. Okay, look at this. So, this 24 mil here, this is pure env bandwidth here. This is pure env bound. So, we'll like find some better env settings or whatever. And this can get even faster. Because I think breakout go way faster than this. But presumably we can get this even faster than what we're seeing here. Okay, this is encouraging. Okay, that is way better. 74%. 74%. This is good. Once per 4 forwards. That would be the. You know what that is? 4 forwards is. Yeah, okay. It's 4 blocks. Okay, so this is actually fine. I know what it is. This is not me testing a kernel, this is me testing everything at once here. Go check this. Hmm. The heck is the split K reduce? Ooh. Yeah, that's incredibly stupid. That's insane that it does it that way. Well, now we know. So because it's a size 1 output, it's doing something stupid. Well, you can't tell that's dead code. Compiler. This is actually the kernel that Peru wrote was to do this. So we'll probably end up just using it. I shouldn't have had the force export. Takes forever. Okay. Look at this, folks. Look at this. We have the entire forward pass of this network down to two different line items. We got kernel 2, which is matmls, and we got our gate. This is what we want. This is what we want. God damn. Okay, I'm gonna get myself a nice mug of tea to hopefully settle my stomach. It's mostly better, but I could use some tea. And then what we're gonna do is we're gonna figure out all those other stupid things that we were doing. We're gonna figure out how to either fuse them into the existing kernel or to put them into their own very fast kernel together in as few ops as possible. Sound good? Because otherwise, this is ridiculous. We should not be having kernel operations for all of this mess. But that does look nice. This is the goal for Puffer, right? We end up with like a super clean profile. We know exactly where we're spending all of our compute, and we will be good. And if I can do this, the really cool thing about this is, let's say that we are actually able to track where every little bit of compute is coming accurately in Puffer, and we get like our 10 mil. Then I'm going to be able to open it up to you guys and put bounties on perf improvements. That sounds pretty cool, right? Because I'm not a great kernel dev. Probably a lot of the kernels that we write can be made much faster. I mean, this is 21% time being spent on gates right here. Admittedly, this is probably pretty close to just min kernel launch time. But I don't know, maybe we can fuse both of these two together. Who knows? Maybe you can write a custom epilogue. I don't know. I'll be right back. All right. Okay. We start uncommenting stuff. We see where stupid kernels come back. Yeah. We'll see if this adds any kernels. The reward buffer copy thing is quite easy. Like, we can always move that to the end or whatever we want, right? Okay, look at that. We add back in a bunch of element-wise kernel and a bunch of unrolled element-wise kernel. I guess it's gotta be the casts, right? We're gonna have to do some stuff with these types. Runs. This probably messes some stuff up, but I think for the purpose of profile, stupid things should not be launching a bunch of kernels. There's a problem. Okay. It's still there. Torch is doing something stupid here. Is what this shit comes down to. Okay, graph actions. Does C have a long wait? C have a long float? It does, right? Double, duh, idiot. Double float, float, yes. Update these types. This is a tiny amount of bandwidth increase and saves us from having to deal with a kernel. 2 kernels, actually. Yes, you do need to change this. I forgot about that. Have not released the essay yet, man. It's just gonna be a blog post. I have to write it. I've been doing a million things. I will write it, like I said. The files will be released. And just use it to change these types real quick. I could technically have it change the env type. Honestly, double would just be easier, right? Let it do this. Yep, it's fine. Feel like it. Alright, it's still part of the test. No, it does improve workflow, but only for certain things. So you will see, like, I didn't use it at all yesterday for environment development, right? But because I have here cenv code, I've got pybind, I've got this like C CUDA vectorization code, I've got torchlib, I've got kernels, I got a billion different things, and I essentially need something to, like, a lot of the things are just refactoring. It's fuzzy refactors. See you on Twitter. See ya. I think this is sketch. What it's done here. We'll let it for now, but I think it's gonna have to change it. See, like, what am I doing here? It's gonna look like I'm taking a ton of edits from here, but this is literally just refactoring, like, two types of variables. And there's just, there's a lot of repeated crap, right? There's a lot of repeated crap. And normally, I put a lot of effort into making things not crap like this. But for now, I'm sort of stuck with a lot of things being duplicated. At least for now. Yep. This is fine. And hopefully, if nothing's broken here, this should then cut out a couple of CUDA kernels for the typecasts. Binding.h, yep. It's a double, it's a char, it's fine. The observations are still going to be a pain. Break out H. Still using Opus. Yeah, I'm using it for specific stuff. This here is literally a, I'm refactoring two variables to have different types. So I think doing fuzzy variable variable type refactor is quite fine, yes? Okay, cool. Got this. What do we think about this? Alt X. Finding what the heck? The heck? Come on. Value error. Wait, Vecchinet should not, this should not be getting called. Because this did not get passed, actually, you see? So this is actually dated. That's fine. Cool. Roll out copy call. Um, right, so these actually should be okay. At the very least, we should be able to have these fine. There's one cast we can't avoid. But only one. Okay, well, we got rid of the unrolled element-wise kernel. Let's see where the element-wise kernel comes from. This D-type should be float32. Firm. Actions. Okay, graph actions is fine. Quickest is just to do some try this again. See which of these D-types mismatch. Yeah? Excuse me. This is not supposed to match if, eh? It's weird. Hey, user. Element-wise kernel for the copy. Interesting. Everything will be fast, damn it. Activity buffer request, lazy function loading. Ah, look, CUDA launch kernel, you see that? CUDA launch kernel, element-wise. Bullshit is what that is. That is bullshit. Screw you, Torch. I do a freaking copy operation and it's launching kernels behind the hood. What's going on with that? I think it can probably handle our buffers, right? I think it can probably handle our buffers. Time to switch to sklearn. That statement makes bullshit all sense, man. Wait, segments. Actually, is it not? Am I dumb here, or is it just horizon segment input? Does that not work? Wait, horizon? Index a single. We'll just sanity. Yeah, it's a lot of changes. The thing is, we're gonna have to swap it. It is a strided anything. Yeah, let's do A, that's right. It's actually quite thorough, which is nice. Yeah, see, this is good. It's just gonna have to swap all the dimensions. This is definitely the right call for eval, though. Like, the RL eval loop is always gonna be this way. And so it does this. Good. It's kind of funny because, like, Claude gets dramatically more useful the worse your code base is. And this one is like, this is probably the chunk now of code that it's just the most unavoidably pain in the ass. No. No, you're not going to do this. No, running RM commands ever. Bad. Okay, let's see if this runs. Strided copy really bad. See, I figured that there would be like some sort of CUDA transfer option for strided copy, but there just isn't. That's funny. Kind of assumed too much, you know? Alright. Yeah, it runs. Ooh, fast. Very fast. I think we killed off the overhead, guys. Fast puffer. 3.4% unrolled element-wise. Smaller. Where's it coming from? I'm just going to continue to sit here until we figure it all out. This should definitely help us. I don't know if this is enough for 10 mil. I mean, keep in mind, we haven't written, like... This is still minimized. It's going to take us a couple hours before we have something even remotely able to train again after all this changes. But this is what you have to do. You have to shred everything, and then you have to put it back together. So now we get to see whether I still have element-wise. Ooh, okay. So it is still in here. We have one element-wise kernel per matmul. Eh? That's weird. Oh no, this is the wrong one. That's the wrong one, right? Let's just do this. Hang on. I have to be so careful with this. I like keep messing stuff up. Make sure you get your data correct. I want to see how many calls there are. And we can tell by this what it'll be. Do we accept 3% overhead for no reason? No, no we don't. I bet you I can port the clamp into the advantage kernel if I have to. Okay, so now we actually can tell. Here. Okay, basically this. One element wise per forward pass. Unrolled. Oh, actually, is that the unavoidable one? Yeah, that's the unavoidable one. Oh, maybe not? Is it just fine? Yeah, it is just fine. That's just a straight mess up. It should be float 64. Okay, cool. There is still going to be one unavoidable one, but it's not there. Let's see. Now we understand the strided copy bullshit, right? Antanas? Yeah, he's doing cool stuff. Thank you for reminding me, actually. I meant to message him. Yeah, I think he's doing well. Ta-ta. Yes. Okay, there we go. Look, this now has 0 kernel calls. 0 kernels. None. Nada. Gone. We can take the buff states. Right, these buffer states. We're good with these, right? And 0 should be not a kernel call, right? If 0 is a kernel call, that's screwed up. That should be a copy. Or whatever. Whoops. We're going to be very fast buffer. Ooh. That's not good. What the heck is this? What is this? Well, this is the 0 op right here. What the hell? One of these so it's only one of them. Wait, is it one? No, it's two. Probably one of these is not contiguous, right? I'm liking it for this thing I'm doing right here, Ethan. That's funny. This is all garbage. All garbage feed. The only cool thing on this entire feed is the Hightail early access. That's the only cool thing in the entire feed today. Wait, hang on. Block size. Wait, num layers. Yep. Block size times hidden. Why does it have to be block size? What is something you'd like people to do with PufferLib that they haven't already? Honestly, we just like there's a ton of core research, but then I want like more medium complexity M's and more medium complexity applications. The thing is, if I give that to new users, like it's not straightforward yet. You actually still really need to know quite a bit to get medium complexity stuff to work. That will change. It will become easier. But yeah, that's probably the main thing. We have a lot of contributors that can do like relatively simple M's and like kind of start to get a little bit more interesting. And we do have a couple like good ones in PR as well. But like just cranking up the end complexity in general, it's pretty tough. No, it'll get easier with more info. That's fine. Okay. Everything gotta be contiguous. Everything gotta be contiguous. There will be one unavoidable kernel, I believe. Maybe two. Yep. So I basically just had I had all the indexing wrong. Or not wrong. I had the indexing backwards for contiguous. I had it contiguous for train, but it's better to have everything be contiguous for eval. Because 14% element-wise overhead for bullshit is ridiculous. Like, you see, it's not even a lot of time. This is 5 microseconds, right? But, like, when everything is this fast, stuff just adds up. Buffer really fast. Didn't update some checks. Super basic check. Yeah, it's the old layout check. That's fine. That's good. See if there's anything else. I think that's probably the only one, unless there's one in forward train. Yeah, there's forward train. Expected. We'll have to adjust as well for this, but this is good progress. Messages not being received on YouTube. Debug check. Yep, there are your messages. Boink. They're there. Okay, that's fine. Yeah, that's fine. We can do this transpose weirdness. Tiny, tiny fireballs. I mean, I'd very much like, cast fireball definition of AI. I like that one. Envelope PR. It's probably in my backlog, man. Is it the overcooked one or what is it? I do review stuff. It just takes me quite a while. You should keep reminding me, though. Alright, there's a tic-tac-toe end. Oh, the nonogram puzzle end. Okay, that one's nice. I remember you telling me this one. Cool. This is nice. Actually, this is a very good end. I remember this one. I like this one. Yeah, this is a very good end. I'm backlogged on PRs, though, right now, man. I'm gonna have to take some time to review some, but, like, it's... What can I tell you? I'm grinding the heck out of Puffer 4. Yeah, that would count as a medium. Unless you trolled and, like, I can actually solve it way faster. If it's taking, like, billions of steps and still making progress, then that's a medium. Yeah, you can do that fine. It's just messing with the storage layout for train. We're gonna redo that anyways. We really just need the eval layout to be good right now. No, it's NP hard. Ha. That's funny. No, I know you're not, like, trolling on that. I'm like, oh, I see. Well, I don't know. Is it possible? Are there any NP hard problems that are known to have, like, really easy approximate solutions? It's like, it's possible to define classes of problems that are NP hard where subsets of them are really easy. You know? To obliterate it. Oh, we're working on it with Puffer. We gotta get all our nice perf in. I think actually what I'm doing right now in particular is going to be so good for little networks. People are going to be able to train super fast on their laptops with this. Assuming you have, well, you will need an NVIDIA GPU of any variety. So that is the requirement. Maybe you won't eventually, though. You know, we'll see. I could always write a CPU version of these. Must be contiguous. Reset. Insolvable. Yeah. Not average. Yeah. Alright, let me use the restroom real quick. I'll be right back. All right. Let's see. Select. No. No. Bad. Nope. All right. Ooh, okay, this is the issue. Hmm. Hmm. That is irritating. What bot is that? What? Oh, hang on. Is PufferLib helpful in optimizing environments that are entirely GPU accelerated? Yes, because then you're going to get bound by everything else. Like, all the other libraries are slow. Though honestly, most GPU accelerated environments that people show me are actually slow as well. Let me think if this makes sense. Isn't it just not B num layers? Wait. Am I dumb or is this false? Uh, Take all layers. Ooh. Yeah, that is gonna mess it up. Oh wait, what if we do B? Okay. Oh wait. And then that's bad. Well, it's not that bad though. But wait, how does that make sense? Still big matter. Things are improving, Jess. Things are improving quite rapidly. It's just a whole bunch of making sure memory is contiguous. I'm surprised CUDA doesn't have like CUDA strided copy. There is CUDA memcopy 2D, so this thing exists, which is just stupid. All right, we'll try this. So the point of doing this now is we have initial state per where is it? Yeah, initial state is going to be per buffer. And then that should not have any problems with contiguity anymore. Optimization to be done. On the CUDA side, yeah, you see? And it actually matters a ton. Context usage getting dumber by the prompt. That doesn't make any sense, dude. Well, good thing I'm not asking it to do anything hard then. But I don't think that the thing you said makes sense. I think only if you cross, like if you compact the context, that can mess things up. Just having long for context shouldn't. Okay, what do we have here? Layers. Yeah, this is just the reversion, that's fine. So it's gonna have to be vector like this. That might actually screw up the nah, that shouldn't screw anything up. Yeah, and then you do like this, right? Batch. Yeah, we'll be like this per buffer initialization. And I think that's pretty much it. So then we should see no more state compacting or state contiguous ridiculous kernel overhead for no reason. It's actually clean because now you don't have to even narrow or anything like that. It's just an index. Quickly. Cool. Let's see if this runs. So we're looking for, whoop. I messed that up. I can just return nbobs. That runs. Let's get rid of the, oops. Okay. We'll see whether this is extra kernels or not. We're pretty much just trying to figure out all the redundant places this thing is launching extra kernels. And then we graph everything that's remaining. Okay. Oh, beautiful. Absolutely beautiful. Look at that. All right. This graph ops here, you can go like this. And then that will be the entire, if this works, this is the entire forward loop except for the 0 ops and the clamp. Just make sure that the ops copy is not messing us up. And then we will we'll start rebuilding the rest from here. Some stuff that needs uncommenting, yada yada. Yeah, let's just take it nice and slow. We'll finish this one. Go through the rest of the net. That should be good. So I think then if this works, we will see if we can get this to train. And then we'll start on the backward pass. That one will be substantially harder. Breaking into tech. Probably not the best person to ask. If you're looking to learn stuff in this area, I have plenty of material, but if you're looking for conventional career advice, not the guy for you. Okay, this is the entire forward pass. The only thing we cut out was the zeroing. So we'll just add a little to-do. You remove state zeros and probably put our biases back in. We definitely can go do, where do we do it? State out. And we don't want this stack. So I think this is it, right? We want like this. Pretty good. And then that'll be everything except the state zeroing and the reward clamping. I don't think I commented anything else. We can always try to put the, oh yeah, the Gelu. Yeah, there's still the Gelu. Alright, well there's still a few small things then. can we fuse it? I would like to have that fused. Oh yeah, obviously there are a lot of commented ops. But we know which ones they are. Uh-oh. Memory device to host. Oh, this is still good. Cool. So let's do. And get our training loop. This is not going to be the real number because it's not doing there's some ops it's omitting. Yeah, 9.6, 9.7. So we have to do a few of these operations. Oops. Okay, let's go try. Aside from the reward clamping, we have all this stuff, right? This is pretty much all the extra overhead, right? Now it actually kind of trains, even though I don't have reward clamping in. And it's still faster than before. It's still 9.5 mil. Not bad. Not bad at all. Now, of course, what we can do is we can go back and profile this, right? And see what the profile looks like now. Oh, this is the profile for everything, so obviously this is going to contain a ton of crap. I'm curious, though. We'll see how much element-wise we've gotten rid of. Go see Peru's, where's this, like, RL plays? No, where is it? Did I not check it on this one? I'll find Peru's GitHub. There it is. Sample logits here. I want this one probably. Okay. Well, look at that. We are now up to 45% in matmols. And look at that. The next two lines are their kernel. That's good. We still have this reduce operation here. And this vectorized element wise, so this is 16, 20, 22. This is still better than before. You know, we've got more of our real stuff up top. Let's go check eval overhead though. That's what I meant to do originally. And go check eval overhead. We'll try this one. I can definitely tell there's a perfit to this from sampling. Definitely a perfit to sampling. Let's go see if we can find his kernel. This one was interesting. Okay, this is what we want, right? Right here. Hard code based on numax. This is not amazing. Hard coded for 5. Strides. Interesting. I can probably get this thing ported in. GPU mem. Okay, you know what we'll do? Let's check this first. Yeah, look at this. So we have, you see this? Huge amount of overhead. Huge amount of overhead. Okay. What we're gonna do, I'm gonna take this forward call logic. I'm gonna take this. I'm gonna just have it port this to be non-templatized. Oh, we need to let's compact this first. Because what we're gonna have it do is we're gonna get it to port. I think I can probably. This might be giving too much to Is this gonna be giving too much to? I don't. Wait, hang on. Forward call. Actually, I don't think it is because forward call. This is This is only. This doesn't need grads. Yeah, this doesn't need grads at all. So this is. It has a very simple way to do this then. It's fine. So actually, this is a good point for me to just go grab a mug of tea, and then what we're gonna do is we're gonna get we're gonna basically get this thing to port peruse kernel exactly as the rest of our code is set up, and then we'll be able to time this as a third line, and then that actually should give us a little perf bump as well. I'll be right back though. Okay. Got tea. Did I miss him explaining context? Not really. We are we are optimizing the crap out of the overhead in the evaluation loop at the moment. We've got it down to, except for this here, these ops, it's two kernels. It's literally the matmul and the gate kernel. And because of that, we've done like a 2x reduction in overhead, which is a 5% increase to training speed, but it's actually going to be a double increase, like 2x increase to perf for some applications, which is why I'm spending so much time on this. 10 mil is not just 10 mil, it's representative of a lot more. Okay. Oops, one moment. I had to answer something. Do you prefer I watch you on Twitter or Twitch or here? You just wherever is your favorite platform. It doesn't really matter, honestly. Um, okay, so what we're gonna do here, yeah, right. Okay, so this looks like a huge amount of stuff, but it's basically a huge amount of stuff because everything's duplicated in 5 places. No MCPs. The hell's no. Um, feels more important. Yeah, Twitter is. Game Boy Supercomputer. No idea. Not another, just a normal stream, man. I'm using it like the way I normally use it for basic stuff. This, admittedly, this is probably the heaviest thing I've used it for all day. But this is basically like, so the way that this works, I guess I can explain why this is fine the way it is. So we have several kernels, okay? And those kernels, they're defined in kernels.cu. They have launch functions that all look the same. They have bindings to torch in modules.cu. Then they have to be defined and exported in PufferLib.cpp, right? And they have to be added like to graphing in kernel ops with flags, okay? Yeah, okay, that's the initial port. They have to be added to that with flags, and then they have to be added to, because I have not consolidated yet, they have to be added to both tests microbench, which is the Python version, and then profile kernel CU, which is the pure CUDA version, with graphing support and a bunch of other stuff. So it's just like everything is duplicated like 6 times, and the actual amount of like new logic that is required here is almost nothing. So it looks like, oh, look at this massive amount of code from Claude. But the thing is, like, look at what this is writing. Okay, first of all, it didn't write this. This is a direct port of existing code. And then this is matching our exact syntax or our exact style for our other kernels. Like this is all our structure. This is how we have our stuff done. And this is no logic. This is just calling a launch. This is literally just like grabbing these lines out and pulling them into a function. So like, if you just look at the actual thing added, this is not actually writing anything new, right? And the thing is, normally I just don't have code projects that are this redundant, right? Because it sucks when you have this much redundant code. But because I have custom kernels, and I have PufferLib, and I have Python binds, and I have all this stuff going on, it's kind of unavoidable. So in this specific case, Claude is very helpful because of the amount of redundancy. But if I'm writing a new environment or if I'm doing other stuff, it's dramatically less helpful. Not zero, but certainly way less helpful. Kind of. It's really more so like to port Jest. It's a port, but with like very clear existing structure for everything. Like the reason I'm happy with it writing this much code is because I'm confident that it's going to produce pretty much the exact same thing I would have written manually with the guidance I've given it. And it's verifiable. Did Peru's kernel have random logics in here? This as well is our exact thing. I'm not asking it to do that much stuff at once, Quinn, where it needs that. Like, this looks like a lot of code, but again, this is directly matching other code that I've written myself. What I'm pretty much asking it to do is apply a template, if that makes sense. Fuck. Why would you do it this way? Okay, I'll let it do it this for now. This is fine. Sure. See, like this test here, the only reason I take this, because this is dumb, is that I know this is getting thrown away. Like, I know that that's getting thrown away. $7.69 on Twitter. It's cumulative, Jess. Some of the streams have like 10K plus. This is kind of just like your normal chill dev stream, where we're doing something that's a little bit more technical. So it's not going to be as interesting to watch as me ranting at whatever the hell. But this is ultimately how Puffer is made. And this is how we make the breakthroughs. Lo and behold, real work is done. Hackathon, do you think they're useful? I had a RuneScape level fun doing it. If you had fun and you're learning stuff, then do it, dude. Don't worry about like okay, yes, you have to make sure that you are able to actually get jobs and things that you need. Yep, but like the most important thing, longer term, is that you are enjoying learning stuff. Then you'll be able to do more of it. And you're getting better constantly. Okay. Look at that, guys. Now, it does say it's fast in the graphed version, funny enough. So, no, very possibly, this won't be a huge deal with the graphing, but it exists. Nice. That's good. Cumulative because I saw it go down. Really? That doesn't make any sense because there's no way I've ever had like 14K live and I've seen that before. I'm pretty sure it's cumulative. Or engineering problems. I'd be shocked, man. Like, it is very good, but it's much better when used in this sort of more restricted capacity that I'm using it in. You got first place grand prize? Oh, dude, congrats. UCSD? Yeah, congrats, man. I know one guy from there. Was it UCSD? What was it? Mm, UCSB, yeah. Actually, wait, forward call. Yeah, so this is just going to go here, and then we will see. We will see if that gets us down to one additional kernel call. Thank you, brother, for an inspiration jumping into coding. I was deciding if I was going to go to grad school. Hey, I'm happy I can help, man. It's mostly just like, learn about things that you're interested in, build stuff that's awesome, do what you need to do in order to make things work financially. Um, And then don't pay too much attention to all the people that are like very proud to not be thinking about things, right? Interesting. Yeah, so there's this weirdness with RNG. Okay. So what we're gonna do now, we're gonna see what this profile looks like with the new custom kernel. And all credit goes to Peru for this one, right? Ooh, that looks nice. Let's see what line numbers we get, or line items we get. All right. Let's do. Let's, this is the wrong one. Don't worry, this is not the right one. That's too many things. That does not make sense to me. That actually doesn't make any sense to me at all. Oh, you know what? I bet this is all from Rand. Yeah, that's what I'm trying to figure. Because it needs noise. But I don't know if it needs to be done this way. Yeah, from Kurand. See, this is what I would expect as well. Is you would just do it inside of the kernel itself. I suppose we'll see if that's slower. So you see what it is? It's basically just like, hey, Torch is doing whatever it's doing with this crazy random. What if we just do it in the kernel? I actually don't know if that's going to be better or not. Because I actually don't know how RNG sampling works on CUDA. Like on CPU, it would totally make sense what I'm doing here. Okay, this sampling might be a little screwy. I'm gonna let it try this at least first to see if it fixes the profile, and then we'll look at it. Build interactive voice first podcast platform. Use voice commands like "Hey host." Named on previous podcast from host. Clone the voice. Combo gets saved to another tab. And a really good UI UX. You trained it on previous podcasts. How on earth did you train it on previous podcasts from the host? Everything else in there is like what I would expect from like a good hackathon project. Do you actually set up fine tuning, language model fine tuning or something on the transcript in 2 days? Or whatever it was? You say train it on previous podcasts. So I presumably that's transcripts, yeah? Okay, we're gonna try this, yada yada. On previous first. Ability to anneal entropy. There very well might be, Jess. We just need some experiments on it. Yeah, so all it's doing is moving RNG gen into the kernel. Again, I actually don't have any idea whether this will be efficient. Yeah, so it doesn't need the RNG anymore. Oh, I see. Well, that's not going to get traced, you dummy. So that's going to break training right now. Because this is Claude not being smart enough to know how CUDA graphs work. But I mostly want to see the line profile from this. That's an easy fix though. We'll just move the RNG gen outside of the Ford call. Mm-hmm. What the hell? Yeah, okay, you can do what you want with the shitty Python file. That's fine. That's getting deleted anyways. I didn't even know that's a keyword. See if this runs. I mean, pretty much all we want is we just want the one line for this. Like, there's just no other way to optimize this if Torch is going to be stupid. Lame system prompt, fed transcripts, embed previous transcriptors, do semantic search. Oh, I see. Launcher platform, Vulture do embeddings. Compute for that, but it failed. I'm going to scrap it in the last few hours. Yeah, it's a whole bunch of stuff to be gluing together. One thing I'd encourage you to try to do, Quinn. So there are two different types of projects you can sort of do, right? Like, you'll notice that a lot of the stuff I'm doing here, even as a very experienced dev, it's very slow, right? A very small amount actually changes from day to day, even on a very productive day. And this is because when you're gluing together a lot of existing things, progress can feel very fast. When you're doing something that's kind of different and hasn't really been done before, and is not using like large reusable components, things get a lot slower, but you're going to learn something that's very fundamentally different. So both types of projects are good to do. You'll get experience from both. I'd encourage you to give them both a try, for sure. Definitely don't just glue stuff together. That said, that sounds like a pretty big thing that you were able to get working quite quickly, and congrats on the win. Whoops. Okay. Um, that's funky. So that is actually apparently faster. Cool. What is this thing? Ah, I see. It's an int64. It depends, Quinn. For a hackathon, what I just told you is very bad advice, right? Because it's going to be much slower. But if you're trying to like understand something, trying to build something that's sort of out there and learn like lower level stuff, or learn in like a specific domain, you want to go wide sometimes, but you also want to go deep sometimes. How's Claude today? I don't know, it exists. Thank. As you can see, I'm still writing a bunch of code. I'm still doing a bunch of work. It's a nice tool. It is a nice tool. Oops. Oh yeah, go ahead and run that. That's for you. Yes. Mhm. Thank you. Hmm. Like, I've had to learn so much in the process of building Puffer 4. Like, think about it. I'd written one kernel before this. I wrote the Puffer Advantage kernel. So, I had not done kernel, like, really serious kernel dev before. I'd never messed with the Torch C++ API. I hate C++ in general and have very little experience with it. Um, I've done a lot of like system profiling and performance optimization before, but I've never done it like at this level with this many moving parts across CPU and GPU, right? So I've learned a ton of stuff in the process of doing this. And I've also made something that is now going to accelerate the entire field. Because also nobody else has bothered to do this ever, as it turns out. Any new end looking to implement or want to implement? Oh, there's always tons of them, Turtle. It just depends on skill level, right? Probably eventually, the next time I get bored, I'm probably going to do some sort of like RuneScape boss inspired environment. Like I tried doing that vibe coding stream with the Great Olm. I'll probably just like go do that environment properly or go do another of the bosses properly. Because there's actually some pretty cool behaviors you can learn in that. Um, but like at the moment, I'm focused on getting this infra done, and I'm kind of just curious to see what users come up with for new ends. I haven't had too much time to think about like M's lately. We're doing some stuff right now with mazes for some of our research side stuff, which is good. Um, and then 2048 also ended up being a really good end, surprisingly. Actually, Claude is going to be really useful when I have to update all the M's for Puffer 4, because like it's not going to go mess up all the code of the environment, right? Like I literally just needed to update some function signatures and some D types. But that would be a massive pain to do manually. I'm quite good. RuneScape bots definitely had so much. Please don't break my favorite game though, man. I'd way rather we like, can we like make an RL bot and then train a classifier on it and then use that to help them detect bots and ban them all? They'd be devaluing my prices. It's fine. I've been working on trying to get myself a pair of verdict treads in the evening. If you know those, they were added recently. Anti-botting is the way more interesting. Oh, it's mainly just I don't want the stuff I've made to also wreck my favorite game, right? I'd rather like the opposite. Fix RL, then we fix Suarez. Fair enough. Let's see what the line prof gives us on this. Honestly, I just like I learned some really cool stuff from like about game design from some of their new content. Like I just went, oh wait, you can just build content that way, really? Huh. Hey, look at that. Alright, we got one line left here. What's log property type? It's also state out, graph state out. Hmm. Well, this dot continuous will screw it. Why the hell did you do this, my guy? Why the hell is there a dot contiguous on this? Are you stupid? Run a torch check on this. You don't run a dot contiguous. Nutcase. That's only one of them, though. It should be two. Oh, actually, I know why. I know why. That's bad, though. Now I know what happened. I honestly, I have not bought that game. I've played it a ton. I think it's way more interesting to think about, what that game does for AI. This is gonna fail, right? Yeah, contiguous. Okay. What the heck? Well, I'll let it do that, because that's nice. Cuts down on some copies for us. It's kind of funny to me that it didn't catch the issue, though. Like, this is a very obvious issue, and it just missed it. So it can do that, but that's like a very minor change. Actually, Peru did something for this, didn't he? Didn't Peru do something for this? Let me see if we did it right. Ooh. Yeah, he did. He did. I see why he did it now. Hmm. That's fine. I'm trying to think what we do about this. So I guess I can explain the issue. Yeah, I can do this. So let me explain the issue. So Torch was doing this really weird thing with the value kernel. It was like using some really inefficient pathway for output size 1 for some reason and adding extra kernels in. So I fused it together. I fused logits and values. But obviously now when you fuse logits and values together, now the strides aren't right anymore. So what do we do about that? What do we do? Hey, you can make these changes. These aren't going to help though. This is just it messing with the test now. I should just test it real quick. Yeah, it's okay, same thing. Oops, it's just compact. Despite Wharton's MBA. Have you met any MBAs? Literally, the most useful thing I learned from taking MBA courses at Sloan was that I didn't want to co-found with an MBA because these were some of the stupidest people I've ever met. Like, holy hell. Okay. An ultra-educated American can't find a job. Oh, I'm sure he can find a job. Go apply to your nearest McDonald's. He doesn't find a job that he wants. And a lot of these people think they're way more qualified than they are. You know, what's the meme? It was like, hey, my last job paid me $2 million a year to do nothing. Does anybody have an opening like this? That's actually fine to just pass the stride. Which is basically what I just said. Probably missed out. You probably missed out on a lot of things. But like, I'm not joking when I say some of the least competent, most insufferable, most overconfident people I've ever met were at Sloan. I mean, it was like unbelievable. They'd have like a case study, and they'd basically just be describing with perfect competence how they would fix an engineering company when, it's like, I know for a fact as a programmer that what they're saying makes literally no sense and it would be worth nothing the next day if they did this. You know? It's business. And lots practical. Well, Puffer is a business. Puffer is a private lab. We build high-perf sims for companies. All this stuff is open source. But our paid stuff, we build custom sims. I didn't do a full MBA, but I was at MIT for my PhD, and you had to take a bunch of electives, so I said, all right, whatever, I'll take some business electives. Okay, that's fine. So this is going to be the stride added to logic here. Let me make sure I did this in the correct order. Yes. So value is last here, you see? Okay. So this should run now. This should run. Okay, it runs. Cool, it runs. Now we can profile. And that should kill off a little bit of overhead. And it looks like it did, because that's a fast profile. Okay. How do we still have one element-wise call? Well, it removed one element-wise call. So, anybody see it? State? No. Value comes non-contiguous, and that's it. Yep. Yeah. Yeah. So that's all it has to do, and then we'll be good. So it'll just fuse everything into this stupid call. That'll be good. And you really just need to friggin' fuse everything. What on earth? Call of Duty in Gillinor. Don't open Twitter, man. Just don't open Twitter. Alright, so we just have the mega kernel. This is it. Mega kernel. Whatever. I mean, the fact that you're doing this kind of just, like... The whole idea of, like, let's have a bunch of these kernels and combine them together, it's kind of stupid. When the whole way that we're getting perf is just by putting everything into the same kernels. Right? Like, maybe we should just be writing stuff in CUDA. There's an idea. Mega ultra kernel. That'd be so funny. We just have, like, you know, the mega kernel, the giga kernel, the mega ultra giga kernel, and that's just like, you know, they just do a bunch of random stuff. And it's just like all the ops that needed to get fused. No semantic grouping at all, purely for perf. Like, when you get into small networks like this, right? The entire system that Torch is on just becomes stupid, right? Like, the whole system. It just becomes very stupid. Launch over. It's not, but the crazy thing is this is not launch overhead. Man, you can get rid of the launch overhead with graphs. This is also memory bandwidth. You also duplicate memory bandwidth for every single one of these. Even with the graphs, this stuff is slow. You see? The whole idea of, like, we're gonna launch all these ops from CPU is kind of stupid a lot of the time, it turns out. Like, the CPU torch 8-bit, like, what the hell, right? Completely wrong. Teenage Mutant Ninja Turtle. That's good. That's good. Okay, this is on some, like, ridiculous post. So ignore that one. But this is freaking hilarious. Eh. How funny. Get him to build Puffer Torch. Sloan Grad comes up with a PowerPoint of how we can increase the shareholder value. But the MBAs pay, dude. Either the MBAs, they have to pay themselves or they have a company that sponsors them. PhDs get paid. MBAs have to pay. Eh? Super basic, right? You see how I'm describing like really simple transformations to the code, but they take a ton of edits because everything is just really redundant? See, like people see this and they get the sense that, oh, well, yeah, this is why obviously you shouldn't be editing code. But the thing is, like most code just should not look like this. This is crap. You know? 150K. Well, I mean that's the thing, right? I didn't have to pay for the Sloan courses because I'm a PhD at MIT and you can take electives, right? So like I had to take some electives to finish my degree, and you could take whatever the hell. It just had to be unrelated to your work. So I went and I took some business courses. Dude, what is this? Oh, this is just a profile. Like, okay, that's fine. Whatever. This is again, like, I'm gonna have to do this again. I'm gonna have to, like, because there's a bunch of other stuff that now can get merged because we've done this way. Yeah, Roger, they were useful, but not always because of the thing that they were telling me, but because what I learned by listening, not by like listening to, like, oh, you're telling me this, I should pay attention to it, but by like seeing, oh my gosh, you guys have no clue whatsoever. Um, Now I will say that the one course that was actually good and useful, I took a business law course. That was actually good. I wouldn't say it's interesting. You should know some of it though. Oof. Okay. Kernel should be gone. Now we should have fast puffer. We're gonna have broken training, but I know it needs to be fixed, so don't worry too much about that for now. We're just worried about the profile numbers. Hey, look at that. This used to be 40% overhead. Fast puffer. Fast puffer. Ho ho. That's 10 milli. That's 10 mil, guys. It doesn't train yet. We have to fix some stuff, but this is our 10 mil. 10 million steps per second. Mm. Man, I hope we get to commit this tonight and have 10 million step per second stable training. Yeah, it turns out computers are pretty fast, and we just suck at programming them. I'm getting myself a new mug of tea. I'm gonna use the restroom real quick, and then we are going to make all this work. And then if we finish that, we'll start profiling train a little bit, because there's gonna be some stuff to fix and train as well. All right, I'll be right back. I realized something, guys. Not only did I just make this thing 10 million steps per second, this is going to scale dramatically better as a result. Gotta make the faster animation faster relative to the SPS. That'd be funny. I do need to get some. I need to hire somebody for the, the puffer design, or rather the puffer. Was it modeling, remodeling, rigging, and animation? All right, I'm gonna actually let Claude do a little bit here. What was the third bug? I think there was a third one. Oh shoot, there was a third bug. I just forgot what it was. We'll start with these. AGI prompt check. Where does 1000x speedup come from an engineering perspective? Literally everywhere, Turtle. Literally everywhere. Every possible thing in the entire implementation of RL. Like if you go take SP3 or Clean RL, even like Torch RL, every single possible thing is slow. I think the only thing that I haven't touched is the cuBLAS map mold, because everything else is slow. You know? So it's not just like, oh, there's one thing. Nah, Nish, the definition of AGI is when I can cast Fireball. Then we have AGI. I wrote the blog post on that, or the article. Slow to give you stuff to do. You better not, man. Everybody's getting yelled at in Puffer 4 and beyond. Anytime there's a PR that slows anything down, like, people getting yelled at. Because I'm giving everybody tools to make their shit fast. So you make shit slow, you're getting yelled at. Yeah, Claude's just gonna reply, do you even live, bro? Oh, okay, I see. That's fine. Where were the biggest perf jumps? Country. We have our own environments in C with our own format. We've got our own, like, crazy buffered vectorization. We've got our own eval loop where we have profiled it down from, like, it was 10% efficiency or less if you do it with naive torch. Now we're up to like 70. The whole train loop data structure is different. The algorithm in Puffer is also different. Not to mention everything is CUDA and libtorch, not the Python version. Um, it's like every possible thing. It's not even like the biggest perf jumps anywhere, at least for this version. If you're talking about like Puffer 2, it was doing the environments in C. And then like Puffer 3, it was fixing a lot of the overhead that was in Python Torch. But like for Puffer 4, it's everything. This took so much in order to make this thing work. And let it be known that the only reason that Claude is even able to do any of this crap right now is because the whole structure of everything, like the first few kernels, the whole train loop, everything, that was all done by hand. So now it's like applying templates to new kernels and stuff. This was all done by hand. Action masking to the wrapper. Ooh, we'd actually want to do that kernel level, Jess. What I'm going to try to do though, for the release, I'm going to clean up everything so much that we are going to be able to have custom kernels for stuff like chess. It'll be cool. All the code they use for non-technical, all the code in coworker. Yeah, but like the model is good. Like I'm not saying that their software is good. Like Anthropic people are nuts anyways. Like it's not like all the people there are smart or remotely sane. Maybe the first like 100 or couple hundred people, at any of these companies were good. I'd be so happy for that. Yeah, Jess, we're gonna be able to actually like. The point of this is not now we can do breakout at 10 mil. Now we can do everything fast. That's the point. It was negative. Bad thing. Yeah, those guys are nuts. Like I say, I like the model. I hate the people who built it. Well, I should be a little careful when I say that. Um, it's tough because so both companies, like OpenAI and Anthropic, have some of the people who are the awesomest people on the planet, and then also just some absolutely messed up bastards. Right? Like the core scientists and engineers, awesome. All right, the like ideologues who want the world to look like this. I don't even know what the heck they want. They clearly have absolutely zero respect whatsoever for human agency, though. They probably just want to replace the species so that there's more room for shrimp or whatever. I don't know. PufferLib faster than Jaxmo. Oh yeah, massively, dude. Massively faster. You're kind of just trolling if you're doing your stuff in Jax, honestly. It's just not good. Okay, that's fine. Marketing guys. I don't know why they have marketing and PR guys. Like, it's awful. Kernels. Okay, fine. That's fine. It's just for the profiling. I don't know if this needs to be in 64. We'll look at this thing. But I think this should not change meaningfully the compute time, I don't think. Let's see if we train yet. Oh, 10 mil, but we still have perf bug. I mean, we still have correctness bug somehow. So that will end up being sub 15 second. Maybe how did you go about wanting to speed up RL? How did you learn all this? I mean, I've been doing RL since 2017, 18. It's been a while. I mean, I did my whole PhD on neural MMO, right? And I wrote what was back then the fastest environment of that complexity, I would say. And I came up with a bunch of techniques for efficiency back then that were crap compared to what we have now. But, you know, I spent a lot of time thinking about infrastructure to support complex and interesting ends. And then after my PhD, I was thinking, okay, well, if I can get RL to sort of work on some of these more complex ends, can I get it working more stably on simpler ends? And I mean, from there, I very quickly just started discovering, as soon as I got out of academia, how just doing some good low-level eng will let you just run right over everything else in the field. Like, it's really, really unoptimized. And I did a lot of optimization for an academic during my PhD, but like when you really start going lower level, it's just follow the gradient, man. Like you keep doing this stuff, the stuff gets faster, stuff gets more stable. So I kept doing it for the last 2 years. And I've learned a ton, and I made RL a heck of a lot faster, and I built a company around it too. Face. Slow RL. Would it be possible for wait. And I think I missed a message. They had a task, two agents working together to do with good timing. Communication develop. Yes, you can totally get communication, Jess. Emergent communication, 100%. I think I missed one of your messages though, so I don't know the exact setting under which you were describing. In general, though, yes. Okay, well this is a pain because this is broken. Broken, not good. Okay, so 3.9 with no optimizations on whatsoever. Oh yeah, we didn't uncomment the Gelu. We probably need to do that. Doesn't look like it needs it that badly though. Yeah, it doesn't look like it really cares that much. Cool. Kernel's on. Send and receive super. You can get emergent communication quite easily, Jess. There's nothing that special about it. I don't know, we ascribe a lot of value to things that like are rare to emerge among animals or among people or whatever. But like very often actually it's like very easy to learn these things. You kind of just need the good RL setup and then you steamroll. Coup de grace on. .4. Now we need our custom kernels is the problem. So something is screwy with one of the kernels. Okay, this one's disabled. We know that this one is good. Fun research M's post chess. Ooh, tons, man. I mean, if you can get self-play, if you get log linear elo curve with like some reasonable amount of compute on chess though, and like you can figure some stuff out about self-play with Spencer, that'll be a massive contribution already. More than qualify you for professional stuff for sure. And we have a lot of projects from there. But a lot of the projects are really going to depend on the outcome of 4.0 at this point. There's some stuff around exploration that's pretty tough that we have some active collaborations on. There's the state-based stuff, like the Go Explore style exploration stuff for Puffer 5. That's really important and that needs to be done correctly. I think there's actually, because of this kernel stuff I've done, I think there's some room for some fundamental architecture work. This one disabled and this one is good. This flag, dude. Flag. Disabled flag. What makes chess complicated? Competitive self-play RL is hard. Alright, so this is 9.9.5er. And yeah, this kernel screwed up somehow. Big action space. I don't actually ever take like action space size as pure difficulty. It's a very misleading metric. It's used to nerd snipe a whole bunch. Okay, so this is broken even with coup de grace off. Probably doesn't get. No, I was just gonna say it doesn't get traced. Pseudo rigorously define nth complexity. It's kind of tough, Jeff, because like you can probably come up with some dumb ends that require a lot of compute and scale log linear, but like log linear compute scaling, like nice curve on compute up to continuing to improve for a very long time is a good sign. Um, this is one of the things we just like about games because we kind of just understand, okay, there's a lot going on here. It's complex. If you try to come up with like a mathematical definition of complexity, you're going to get something that's formal but useless, is the problem. Do that real quick. Try that. Yeah, there's so much stuff I should write, Jess. It's tough because, like you see, right, when I'm making progress in one area, I'm always behind on something else. And at the moment, it's just been, in order to get Puffer to be 10 mil steps per second, I just have to devote a ton of time to it. Because, like, who the hell else is going to help me make Puffer 10 mil SPS? Actually, Peru did quite a bit. Like, a lot of Peru's code was quite helpful. Especially today with some of the last couple kernels. Pretty good. Ooh. Is this it? Sub 15 second, guys. Do you sponsor somebody extraordinary on GitHub? I sponsor Ray. There's one project. There's the Puffer. Because we use RayLib in all of our stuff. It's the best damn library ever. I've learned so much from Rayson. Awesome programmer. And you should know I don't give praise lightly. Okay, it's almost 10 mil. Make a commit. Wait, let me read this message. 1 second. Oops. Pro CS. Heh. I mean, I am average height. I don't vape. My teeth are fine. No anime, whatever the hell. I guess unless you count. I mean, I got pretty lofty everything, but I'd say that's more, I read like a lot of sci-fi and fantasy stuff. And I lift. And I run. So there you go. Beer's okay, don't have too much. No six, those are gross. Oops. Alright, there we go. So this is basically clean. Oh, it is 10 mil. It's on the cusp of 10 mil. Or we can go profile some other stuff now, right? Okay, this is without the eval loop. Couple env optimizations would get us there as well. How long have you been running? Is there a 10x speed up there? I've been running for, well, I ran cross country when I was growing up. I was not good at it. I've been running actively the last 3-ish years. And is there a 10x speed up there? No. Recently I got to be, I think I'm a little bit faster now than I was when I was in high school, but I weigh 40 pounds more now, so it's a lot harder. Oh, grinder days. What? Oh, uh, hey guys, can I just like, I can't just do this, right? I just O3 this. Oh, well, no, obviously, because I didn't. It's slower. Oh, no, it's about the same. It's just fluctuating. Cool. I just wanted to see if I could get a cheeky 10 mil. I think I will have to profile our back a little bit. It should be faster, but I think in the meantime what we'll do is oh, I forgot to zero the state as well. Yeah, 0 state. That's not going to take a bite out of Perf, though. Have you played any MMOs recently? I unfortunately did download RuneScape again. So I've been trying to get my Avernic treads in the evening. That's what I've been doing. But I've also been getting a heck of a lot of good progress in on kernel dev on this and on client M's too. So I can have a little break once in a while. New channel. Don't I stream enough, dude? I think I'm in front of this camera enough hours a day. If some viewers want to come do some raids or something, we can set something up for that, though. I gotta relearn chambers at some point. That used to be my best piece of content. Putting you in the background makes me less lazy. Eh. Alright, look at all these gross element-wise ops. Bah. Now we get... Oop. No. This one. Not as bad as it used to be. But check this out, folks. Look at all this overhead we have. Right? We only spend 40% of our time in map lists. Like me in the chat have. Well, once I get bored of, I mean, do you have an account that's like chambers ready? You could always do that. Do some viewer raids. That'd be fun. I really like that game. It's such a fun game, and it's also just so cool for AI. Like so many of the things, just down to the level of how it is implemented at the tick by tick level, is so good for AI. All right, so we have all this bullshit, right? Like we've got right here. This is 14%. Yeah, we got 20% overhead right here, without even looking at these two. Do you play chess? I'm absolutely terrible at chess. We're gonna do watch this. We're gonna do like this. Muon reallocates. Oh, I did not check that one, Rob. I've been doing something else today. I've been optimizing. There are quite a few other things that need optimizing that I've been doing first. We're pretty close to 10 mil. You said yields 1500. I did not say my elo is 1500. I'm nowhere near 1500. I suck. That was someone else in the chat, I think. Was that like, I don't know if that was Jess or Spencer or somebody. We'll do this just to be absolutely sure. Yeah, we cut down, I think we cut between half and 2/3 overhead today from eval. Now there's still a bunch of it in train, so I'm looking at this now. It's almost 4, I got a little time. $47 million when you have all the other stuff. This disabled. Of course, that's without dot backwards, so duh. Open code? No. Oh, okay. This tells us another story, doesn't it? When you take out dot backward, fuse scan very slow. But that doesn't really help us because we can't do much about that right now. Twitter without the slop software. It's really only gotten bad in the last few months. Well, there's our multinomial thingy. I'm gonna let Claude look at this, and I'm gonna use the restroom. I think we're just gonna have to fuse some more crap. But I'll just add it for now. I think probably. You know what? I bet I know what this is. I bet you I know what this is. Oh no, these are good. Well, this thing sucks. Right, these suck right here. These are going to trigger element-wise. about the small things. Can look at the report now because the rest of me are. Ugh. Get rid of this. These are not kernels, you dummy. Quick multinomial. I think we should. Do we need to do anything else other than that? I think I can get it to do this. Because this doesn't need grads. Okay, it doesn't actually get used other than right here. Does these get it updated? Yeah, because these get updated. Okay. So this is towards the end of the day where I have to not get lazy and let it do way too much at once. Again, what I'm doing here is incredibly verifiable, and it has it's basically template matching the existing thing. The only thing I probably should be a little careful with is the multinomial op, but I believe that it has the same one as the softmax, doesn't it? Oh, it's gonna mess up in yield beta, I'm sure. We'll have to fix that. Yep. That's fun. A good spot. He'd be fun to chat with about RL. I think you'd get a kick out of it. Sampling. Huh? Oh, I'm dumb. Because yeah, these are actually annoying because it's a bunch of reductions, right? Okay, okay, hang on, hang on. Yeah, it's a whole bunch of annoying ops. Okay, I definitely tried to make it do way too much. Yeah, see, that barely does anything. Yeah, I really don't want it doing that. I'm not 1500, dude. I'm trash with chess, okay? It's fine, I do alright. It's still gonna be a good environment. This op is super annoying if you look at it, right? Okay, let me see how many of these ops we need. Mm-hmm. Pretty damn much 10 mil. 9.9, 10.0, something like that. I'm looking at the trade loop, seeing if we can cut some fluff off of it. Min Brew Rex. Min GPU Rex. Have an NVIDIA GPU. I don't know. This one has this machine. Well, I'm testing on a 5090 machine, which is going to be 10 mil SPS for Puffer 4. But like a 5070 is still going to be 4 or 5 mil, probably more. So, Puffer is very fast. Without Puffer, you're screwed though. because nothing else is fast and nothing else, like, the hardware doesn't even help you almost. Everything is just so inefficient. No. What's the most important GPU spec? What do you mean? Like flops, just get a consumer card. If you mean the VRAM, no, you don't need the VRAM. It's very, very low on VRAM usage. Well, you're not going to be able to tell from that. You're pretty much best off just getting like a good consumer card. If you want to try this stuff out, you can rent these cards on Vast for like somewhere between 9 and 50 cents an hour, depending on the card. Though a lot of those are either underclocked or it's otherwise screwy. Mm, noxious. Yeah, see, this gets really annoyingly complicated, doesn't it? Hmm, that's really annoying. Hmm. Well, that's unbelievably annoying. We should actually test this without the indices. No, it's just this op is a pain. I think I know what this is going to end up looking like, though, anyways. And Puffer 5 is going to get even faster if I'm right. Not a ton, Alfonso. It's really easy to overuse it. It really encourages you to be very lazy, which is very bad. The stuff I'm doing right now is very boilerplate heavy and also very strongly verifiable. See, like, it's so dumb. We should just do this, right? Let's do this. Let's see what this actually gets us. I just want to see if, like, some of the really weird line items disappear in the profile. Well, I mean, I don't even know what to say to that. Okay, look, this is substantially better. We still have this element-wise kernel, but actually very few calls of it. So actually, presumably, this is now outside the loop. Outside the loop? Maybe outside the loop. I think so, outside the loop. Vectorized gather kernel. So this is our indexing overhead, right? Five twelve net max. So I go algorithm. What? Oh, we're doing something different, dude. We're doing something different here. Yeah, and even this is silly. Okay, so this is what we want, right? Temporary contiguous slice. This is good, right? Okay, so we have index. Okay. This gets commented, or no, this is gonna get updated to be like narrow or whatever. Slice here. Yeah, that's fine. Okay, let's go look. So pretty much what we're doing here is the same thing we did with forward, where we're just going to keep stripping stuff down until we end up with like very small number of line profile items that we can track, and then just cutting out redundant stuff. I think though that this is kind of an algorithmic level thing where the indexing op is just very stupid, and we're just wasting some time on it until we come up with something better. Okay, see, so we still have a bunch of calls. Let's see what element wise we have. Yeah, you can look at stats. I think that like the squeeze and the like transpose, there are lots of these things that need to be fixed. Element wise. Okay. We'll just, if Claude's gonna be stupid, we'll do it myself. I'll do it myself. Pretty much just need to figure out every possible source of random overhead crap. It doesn't contain any data because we skipped the first 3 seconds. So I need to change that. Wouldn't it be nice if RL were this fast? Yeah, that's not happening though. That one would be hard. Nah, 65 mil would be I can get eval to be 65 mil with big batches, no problem. We can't get trained to be 65 mil. Huge amount of data though. Uh-oh. Oh, there's our profile. Cool. Too much data though from this, apparently. Too many ops. I will fix that. Goes faster. See if this gives me anything interesting though. Okay, huge number of ops. We still have some overhead. And it's several per iteration, you see? So what I'd like to do Pretty much everything just gets commented. It's a lot of ops that get graphed. Stupid internet. Okay. Oh yeah, this is a good time to remind people. Please feed the puffer a star. He's hungry. 488. Almost to 5K. Gotta get 5K stars before release. Maybe when we hit 5K, I'll put some effort to get a stable pre-release for you all, eh? That might be good. Realistically, it's just a ton of work. That's the problem. It's just a stupid amount of work. Alright, what we got? I see, I see. Why do we have this many? Wait, this is not even one per iteration. Well, sample logits kernel. Well, this is the graphing that's getting picked up, so we ignore that. This one is a lot. And this one is a lot. Why is there a giant element-wise kernel here? What would this be? We definitely need to fix a couple things. There's also like almost nothing left here. So yeah, this is just diffused. This calls for train and it gets diffused loss. I wonder if this is actually trace overhead. That'd be kind of silly if I did that, right? I mean, we still, this does not trace overhead, right? But what about this? It's very odd. Overhead just does not go away. I really, this is just at this point about making sure we know where all the overhead is, at the very least, you know? I'll be right back. Super slow profiles. Just have to make sure though that this is not trace overhead. We should probably be able to guess it from the counts, right? Fill, functor. Oh wait, here it is, right? Look. View scan. Yeah, hold on, it's there. Scalar. Okay, so we have yeah, so let's just give it the GPU kern sum. Yeah, you can see without this. Okay. fill functor. So there is, oh wait, there's a ton of these fill ops. You see it? Yeah, it's filled. B unary functor. I don't know what this is. B unary functor. Impl, no cast, launch clamp scalar. We got a few of these. Well, there's a fill. But that shouldn't be that many of them. The heck do these come from, man? I wonder if it's this. No, because it's outside the loop. Hmm. TD array. Oh, it's gonna be in here. Yeah, it's gonna be in here 100%. I forgot. 100%. Okay, right here, contiguous. That's element wise right there. And then the next one was right here. Those dot contiguous ops are bad for sure. Photographing eliminates torch checks. Fun. Says, do we error? No, we don't. Nice. Okay, there are 900 some odd epochs. So 800 something could be the one, like, those don't matter if it's 800 something, because that's going to be outside the loop. Takes forever. The profiles. Let's make a plan then while I wait. I think next we're going to re-enable all the copies, because they shouldn't add any, like, once we have no element wise, we'll re-enable all the copies. This is freaking poly market. What, people are betting this? I mean, that would be a huge failure if they do that, right? They'd lose the consumer market. I guess it depends on what happens with AMD. Oh. Okay, we still have this fill functor thing. Element-wise kernel. Oh, hang on, guys. Okay. I don't want to do PufferLib Polymarket RL. Gambling is cancer. It's fine. I want to know the full name of this. It's still frickin' cuts him short. Same number, right? Oh, this one as well. Bad. This is not every single batch, though. Hmm. D-type conversions. Double copies. The loss. Loss divided by NT division. Ugh. Two YC health companies. Congrats, man. I hope you get some good stuff out of that. You know, do some homework, make sure you're doing stuff appropriately. What do we frickin' do with this? D-type conversions. 5,000 D-type conversions, really? Oh, you dummy, it's probably right here, you stupid. Something up here? Oh, yeah. This is totally gonna be something stupid up here. Yeah, but pre-divide. Scale. We just need that profiler to run faster is all. So why don't we work on that? Just need to get this to be faster loop. We can profile properly. Everything freaking commented. Mini batch. Just need to get this thing to a fast profile loop so I can actually just get it to not have the element-wise ops in there. Oh shoot, if we don't... No, if we don't graph, it's still fine. If we don't graph, it's still fine. Did the kernels. I'll be good. Yeah, see, it's too fast. And with coup de graphs off. Actually, you know what we can do? I know what we can do. I think this will be fine because we're not going to trace now. There. That should work. We'll see. It's crazy that even that is not fast though to collect the data. Really annoying. I mean, I really should just like, maybe I just do call train once, right? Yeah, I think it's worth it to just like, one loop. Do this. Just collecting data. What the hell? It's so weird. It's gotta be so weird. And then this runs somehow? And still take forever to generate reports? I don't understand what the hell. Stupid thing take forever. I mean, presumably something's broken. Wait for it. I think like the torch initialization breaks or some bullshit. It's very screwy. Ridiculous. Profiling is such a mess. I honestly don't know what the hell's broken with it. A stupid profile script. It just like stopped working. It's just slow. Okay, so now it's running this and this. Well, this should be able to run profile, no? It just needs a few seconds of data, right? Let's see if that works. I'll actually let this run for a bit. rollout graph replay, train forward graph replay. Literally nothing in this call. Nothing in this call. Nothing in this call. Perfect. So this is the exact profile we want. It'll just, oh, there it goes. Yeah, thing just takes forever, and it's kind of difficult to get a min profile, but let's see what this does. As a thing I'd forgotten is that we actually had not profiled the train time forward pass. So it's a different forward pass for training time. Let's see how it goes. Blah, blah, blah. Is there any actually interesting research on here? The heck? That's weird. Oh, here we have it. Okay, look at this. We only have one element-wise kernel left. Okay, look, we only have one left. For every call of sample logic's kernel, so once per forward pass. Wait, sample logic's kernel is called, it's not called in back. No, it is called in back, right? Yeah. Doesn't need to be, but I believe it is. Is it? Wait. This policy forward train gets called, which does not have sample logits, right? Well, that's interesting then. So wait, then this... Scan kernel per layer. Full day stream. I've been live for 8 hours, a little longer. And there's only one element-wise kernel. That's good. It's a tiny one as well. Oh, you know what? I know what this is. This has got to be the RNG, right? On long. This has got to be It's got to be the RNG, right? On sample logits. I bet you it's this. All right. It's a little annoying to have to do that, but I mean, how confident am I? I'm very confident, right, that this is it. That'll be it. We'll get rid of this. And then this will be clean profile. Stupid thing. And it'll be like a, 1-2% gain. Stupid thing. Yeah, get rid of that. And then we'll rebuild this. We'll see no element-wise kernels. And then once we see that, we uncomment the unindexed copies. That one should work. And then, well, we've kind of commented a lot of crap, right? But it's fun. My commands there. We'll definitely be getting over 10 mil now, so that question is settled. Yep. Jeez. We still running this? Yeah. This is the sanity. If this works, we have sanity. Now, unfortunately, there's still a whole bunch of crap that we have not been able to get all the little annoying kernels out of. But there's quite a bit we can do with just this. And there's a lot we can do with just this. So for instance, sample logits, cut lists. Okay, look, you see there are 0 element-wise kernels. And if I group this by base, it's even cleaner. 63% map time, fuse scan forward, min group gate, PPO loss, sample logits, right? Super clean profile. We're gonna add the backwards in and make sure that this isn't messed up. This is gonna be slow, but there's not much else I can really do. There's not a good way to make this test faster that's relatively straightforward either. That's fine, we'll just put in a little bit of time on this. This now has the full backward pass. I wonder actually how fast is this? Bet I can make it. I bet you I can make it. I bet you just make the duration 3 seconds. Just needs 3 seconds of data. That'll probably be nice and fast. Let's see. So without all the copies and without the muon overhead, we're over 11 mil. Oh yeah, look at that. Way faster report. Perfect. This is going to be way less painful. 2-minute cycle. Good. Yeah, that's so much better. Ooh. Element-wise kernel. Yo, you're not supposed to have that there. Where's the element-wise? And split reduce. Split K reduce. And element-wise. So that one element-wise. Vectorized element-wise. Okay, so here, let's say What do we have then? It's reduced kernel. We also have this reduced kernel. Wait. Yeah, reduced kernel. Element-wise kernel. Split. Yeah, so we got it, like, look at these. 1, 2, 3. This is extra percent and a half. No, it's extra 2.5%. Just for the heck of it. Not like every time I do literally anything, torch bleeds a couple percent. Okay, I didn't call 0 grad. It's not called. We do not 0 the grad. Hmm. Interesting. Loss reduction. But there shouldn't be a loss. We just call a dot backward on it. There's no reduction. Fill functor. It's gonna compact. Lovely. Empty like. Empty like. This is fine, right? We could probably count them. Come on. 1,700. Well, that's not a lot of them. We also have vectorized element-wise. Oh wait, we're looking at dummy. It's over here. Okay, so we have 700, 3840. This looks to me like it's in the fuse scan, right? There's an extra element-wise op in fuse scan, most likely. Is this fuse scan? No. Okay, so this is probably in that one. And then split reduced, I actually have no idea what this is in. Oh, but then the reduced kernel is totally in the PPO loss, right? Do you play Dota? No. Dota is the best result in RL, though. As of time of writing, best result in RL. Blah, 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 blah. Let's see, I can spot it in the meantime. It could very easily be one of these contiguous calls. You know, like these contiguous calls. Okay, nice. Yeah, so we take contiguous off. And then after this, we can call again. And I'll play with this more tomorrow morning, most likely after. Maybe tonight, we'll see. Yeah, we can get the dot contiguous. I think we're just gonna remove most of these because you just need to have your buffers contiguous wherever possible. Contiguous is nice to make sure your stuff works, but I'd rather have people have to do it manually if they want it to be slow. Default path is fast and safe. We'll rerun profile. We'll see how this does. I think they should at least get one of them. I mean, it just shows you though, like, literally any individual op that you leak, you'll leak a percentage of perf. 1%, 1%, 1%. And that's actually really way worse than just making one catastrophic error, because then, like, this is what you have to do in order to get those 1% back. It's easy to catch catastrophic errors. Like, oh, the profile slot can't do anything. Yeah, that means you gotta rewrite the whole bloody thing, is what that means. Okay. One of them is gone. Yeah, the PPO loss reduction kernel is gone. Let's go try the element-wise thing real quick. Something. Let's see if this runs. I mean, it still runs. The torch check would catch that. Oh yeah, this is scratch off, isn't it? Hmm. We will see. I don't know why it's kernel. Do we not have any contiguous on this? No. D-type device. T-buff. It's fine. Okay. I don't see it. I'm gonna go check in the meantime. Because it could also be in here. That's not an element-wise call, right? Here's the training path. Fuse GAN. I guess it could also be in the, it could be in here, maybe? I don't see anything that would be it here, though. So reshape. I don't see any element-wise, though, do you? Nothing that would match that. Size? No. Hidden gate? No. Yeah, I don't see what else this would be. Fuse scam? No. Let's go check the kernel again, and then we can also just comment out. Oops. Yeah, we can also comment out some, like the whole thing if we need to. It's so weird. Empty should be fine, right? Not seeing anything. Yeah, I don't see anything. Well, I mean, we can also just like take the fuse scan out, right? But it would just have to be state, right? Yeah, it hasn't found anything. So I think probably I'll let this do this for a bit, but I think probably we check this off explicitly. Okay, we'll see what this is. Oh, that's nice. It's three of them. Interesting. Oh, it's a sum of three. Vectorized element was. Was this one? Direct copy CUDA kernel. Oh, it's a cast. This is nice though that we can do it like this. There it is. So this is direct copy kernel CUDA. What the hell, C++ nonsense, man. Simple no cast, direct copy kernel. How's that a kernel? No cast. Oh, you know, I wonder if this is... I bet it's this thing. But I don't know why this would be a kernel. So... how do we do it here? State, this is how we do it here. No, there's no copy. This select, maybe? No. Okay, I'll run that. That is probably what it would be for a dot contiguous, right? We'll see which one it is. Okay, that's fine. Alright. So you can just grep. Now I know that the CSV actually does contain the full names. Okay. I run it. And we'll see what we get. Comment-wise kernel. It's the same bloody thing. This copy underscore. I mean, I don't think it would be like a copy. It would be like a contiguous or some bullshit, right? It's gonna be like some dumb implicit op. There were just one way to get the line number and the friggin' source. Hmm? Mm. We can do that, but like, I don't think that helps. Technically could be one of them. I doubt that changes anything. Let's see. I guess it could technically be one of them. Pretty awkward. We're very close either way. 10 mil. Oh, it's still there. I actually don't know if that's the same number of instances. Oh no, it's gonna be slightly. That's fine. I can probably come up with a much better test though for this stuff. I'm pretty happy with the progress we made on this. I'd like to have this actually like in a runnable state though. Um, so let's just go see if I can do that real quick. So I gotta be done for the day. I'd like to have this committed runnable. Just do this. The annealed is not wrapped yet. Let's see with this. Random indices get moved. Will I mess up? It's the wrong index. There we are. Why does it not play? Is it broken? Oh, it's shitty. Okay, so the video saving just decided to be complete crap apparently and just not saved correctly. Lovely. Okay, so yeah, my recorder just sucks for some stupid reason. Yeah, the recorder just sucks. We'll settle for the screening. We are all set. Let's commit this so I don't lose anything. There's still some optimization to be done, I'm sure. But I'm kind of sick of it. So I think that the rest of it's going to be done as part of the cleanup. You know? Because I'll be sure that I'll be having better benchmarking in the process of doing the release cleanup. Oops. But there we go. Promise kept. 10 million step per second training will be coming to RL. I think by the time I've cleaned everything up, we'll have it like, over 10 mil by a bit. So it's a clean 10 mil. It's not me bullshitting it. It's not gonna be 9.5 or something. We'll probably make sure it's at least 10.5. Yeah, turns out stuff is really, really fast if you just don't waste all your compute. I'm gonna go get some food. I've been live for over 9 hours at this point. This is not gonna be like, this was not one of the super fun active streams. This was one of the just like work on a bunch of stuff until things make sense streams. We are, what, 1.5 million SPS faster than when we started? 1 million SPS starter? Whatever. We're faster. If you're interested in my work and would like to support it for absolutely free, please just feed this pufferfish a star on GitHub. It really helps me out. We're almost to 5K. You can join the Discord to get involved. You can follow me on X for more reinforcement learning content. Thank you, Finn. It's going to be a lot more work to get this thing fully cleaned up, but at least it is in sight now, It's real. It exists. Okay, folks. Good night. I'm getting food. I might